Hello, welcome to our channel Flow in Study. Today I am going to start a new series which is in mechanical engineering stream, and the very first subject which I am going to take, that is a fluid mechanics, and this series will be very useful for the students who are doing competitive preparation for the competitive examinations like RRB, SSC, and GATE, IES, BTEC, and BE. If they are in semester exams. So the feature of this series is this: here you will get a very good conceptual understanding, and you won't have to worry about making notes, because you will get the revision notes also, and I'll discuss test paper also and questions related to the concepts, and I'll cover complete syllabus of the subjects. Okay, so let's start with the subject fluid mechanics. So these kind of notes you'll get, and either you can take a screenshot or you can just note it down by just pause the video and you can note it down. But I would request you, first you just listen. Later on you can rewind the video and you can make your notes. When I'm discussing these things, you should not write down anything, just you listen. Okay, so let's start the subject fluid mechanics. The very basic and first definition is this: what is fluid? The fluid is a substance which is having some certain type properties. What kind of properties? That it should be able to flow. It should not have any definite shape. It conforms the container shape. Means in whatever container, whatever type of shape is the container have, you pour on it, it will conform the shape of the container. Even a small amount of shear, this property is very important for the fluid. On the basis of this property, several times the question has been asked in so many competitive examinations. Even a small amount of shear force is capable to generate deformation. Means whenever there is a tangential, suppose this is a fluid element, and if there is a tangential shear force is there, then it doesn't matter how small the force is, but it will be able to create some deformation in the fluids. Okay, next thing is, sometimes students get confused that whether the gas is liquid or fluid or not. So gas is also a fluid, liquid is a fluid, but gas is also a fluid. So next topic is the kind of types of fluid. In general, fluids can be divided into two types. One is a real fluid, second one is a ideal fluid. Then what is a real fluid? Real fluid is anything which we observe, which we see in our real life, means which has a certain kind of properties. What these properties? Like a real fluid has a viscosity. Students who are very new to this subject, they should not worry about these new terms. I will discuss in detail in further classes. Viscosity, in real fluid, viscosity will be present, surface tension will be there. A real fluid will show some compressibility, means there will be some compression while applying of pressure. Resistance encounter on the fluid moves, means as the fluid moves, real fluid moves, it offers some resistance. So these are the specific properties of a real fluid. Then what about the ideal fluid? Ideal is something which is applicable in some certain conditions. Means what is ideal fluid? Ideal fluid which does not have these kind of properties. Means if the fluid will not be having viscosity, it doesn't show surface tension, it doesn't show the compressibility, and it doesn't offer any resistance to move. So these kind of a fluid which doesn't possess these properties, then it will be called as ideal fluid. Okay, next is, since our very basic subject is a fluid mechanics, so it is better to understand over here what is mean of fluid mechanics. Fluid mechanics is nothing but is a branch of science that deals with the behavior of a fluid at a rest and as well as motion. This is very important. Again, this particular thing, that it is the study of a fluid at a rest as well as in motion. Means it is not only the study of fluid at the rest or not only at the motion, it is in both. So now further I will emphasize on some basic definitions like mass density. It is also called as a specific mass. So here I would like to mention it wherever there you find in future the specific is associated with any parameter, then one thing you should be very clear about it. One should be very clear that if the specific term is associated with any parameter, then that parameter, this parameter, whatever it may be, whatever it may, any quantity, this parameter would be measured, would be defined with respect to another parameter by the with respect to unit quantity of another parameter, like here mass density, or it is also called as a specific mass. It is what? It is the mass of the fluid per unit volume. What is the another parameter? That is a per unit volume. Volume is the another parameter which I was telling you, that wherever the term specific is mentioned with any parameter, then that parameter would be measured with respect to unit quantity of any other parameter. And generally mass density of a substance is represented as by rho. Term rho. What is then mass density? Mass density is nothing but the mass upon volume. So the unit of in SI, unit of mass density is kg upon meter cube. Here this is very important. On the basis of dimensions, several times question has been asked in competitive examinations. I will discuss also. So let's quickly understand what are the variations in mass density while variation in temperature and pressure. When mass density decreases, mass density decreases with the increase in temperature. Why mass density decreases? Because mass density is nothing but the mass upon volume. Mass is nothing but the quantity of the matter. Means it's quantity of the substance that is not going to change with the increase or decrease of the temperature, but volume will increase and decrease, as we know from the gas equation, that as we increase the temperature, this is the gas equation. PV is equal PV is equal to, this is equal, PV is equal to mRT. So as from here we can see that if pressure is constant, then as we increase the temperature, volume will also increase. So volume is increasing, it means in a fraction denominator is increasing, so the value of the fraction will decrease, so density will decrease. Similarly, what the density, mass density will increase with increase of pressure. Similarly, from this equation we can understand that how the density is increasing with increase of pressure. If it remain temperature is constant, then pressure will, if the pressure, then the product of pressure and volume will constant. It means P will be inversely proportional to volume. If we increase the pressure, then volume will decrease. If the denominator is decreasing, then the quantity of the value of the fraction will increase. It means density of the fluid will increase. Okay, now specific weight of the density. Weight of the fluid per unit volume of it is given by symbol gamma. In SI unit, it is nothing but weight upon volume. So in SI unit, for unit of weight is Newton and volume for meter cube. Depends. This is again an important parameter, important point, that it depends upon the gravitational acceleration and the mass density. Mass density, obviously, weight is nothing but m into g, and volume is as usual. So what is mass? Mass is a quantity, it's a fix. G is a gravitational acceleration. Gravitational acceleration depends and varies with location to location. It means specific weight density also depends upon the location of the place. So next term is specific volume. Volume of the fluid, again it is nothing but the volume of the fluid per unit weight. Okay, next term, very important term for the examination point of view, the specific gravity. Specific gravity is nothing but the ratio of the density of fluid with respect to density of the standard fluid. Here in fluid mechanics, for the calculation purpose and for calculation purpose, we take standard fluid is as a water, which is density of the standard fluid as a water, which is being measured at the 4 degrees centigrade. Okay, this is a GATE equation. As I hope that you would be well aware about this perfect gas equation of a state. P is equal to mRT. These R is a gas constant whose value is 287. This you should keep in mind for the examination point of view, because and the unit is also very important. Newton meter per kg into Kelvin. Here this is a Kelvin, and joule per kg into Kelvin. This both you should keep in your mind for the examination point of view. And one more thing, this equation is valid for perfect gas, but in real situation no gas is a perfect, but still it is a valid in certain conditions. What are those conditions? This is very important, that any gas can be considered as a perfect gas when there is a very high temperature and very low pressure. It means a gas can be considered as a perfect gas at a very high temperature and low pressure. So next, this is again the continuation of the perfect gas equation. So these are the parameters. As we can understand from here, that density is nothing but a mass upon volume. So P upon T can be written like this: rho into R. R is a constant. R is constant. P upon T is constant. If pressure and temperature remain constant, then rho into V is constant. So this gives the clue to the Avogadro hypothesis, which tells us that at a particular temperature and pressure, a unit amount of any gas, unit volume of gas contains in fixed number of molecules. And the product of mass, molecular weight, and gas constant is called as universal gas constant. So again, the more topics are there, but before going to the next topic, I would like to discuss some questions, and then remaining topics I will discuss in further coming classes. So let's go to the question. If it is not visible to me, please comment on the section, so I would increase the font size of this paper. And anyway, I would read for you. Question is, fluid is a substance that cannot be subjected to shear force, always expand until it fills any container, has the same shear stress at a point regardless of its motion, cannot remain at rest under action of any shear force, flows. Fluid is what? Cannot be subjected to shear force? No, it can be subjected to shear force. Okay, so always expand until the fill of any container. No, this quality can be attributed to the gas only, for the gases only. In case of liquid, it doesn't follow. Has the same shear stress at a point regardless of its motion? No, this is also not true. So cannot remain at rest under the action of any shear force. This is true. This is right. Why? While discussing the property of the fluid, I had mentioned also that this is a very important property, that it doesn't matter that how small amount of shear force is being applied to the fluid, but it will show the deformation. So next question is, fluid is substance which offers no resistance to pressure. No, it offers the resistance to the pressure. It offers no resistance to the flow. No, real fluid flows offers the resistance to flow. Volume they offer, temperature they offer, shape, yes, they doesn't offer the resistance to shape. This one is correct. Answer C is correct. 3. Practical fluids. What are the practical fluids? Practical fluids are, answer is option A is are viscous. Practical fluid. Number B, possess surface tension. C, are compressible. D, all possess all the above properties. E, possess none of the above properties. As I had discussed earlier, the practical fluids are those which are viscous, possess surface tension. Obviously, they are viscous, they possess surface tension, they are compressible. All above the properties, obviously, option C will be correct. In coming lectures, I will discuss some other questions also, but before that, for the today, I would like to stop over here because the video length will be too large, so you may get lose the interest. But before that, I would like to request you, please subscribe the channel, and please do visit our channel again and again, so that you can get, or you subscribe so that you can get the notification for the coming videos, and it will be very helpful for you. Thank you.